All right, here's 8-1, day 1. New topic for us known as matrices. And you'll see this first lesson is split up. It's over 3 days. And the first one, we're really going to cover some of the basics. Okay? Kind of addressing what matrices are and what they can do. Okay, but we're not really going to get into the nitty-gritty details of how we do those things. All right, a matrix is a rectangular array of numbers, to put it as simple as we can. Okay, it's got these big brackets around them, and we like to talk about its size, or what we'll call its order, which is how many rows by how many columns. Okay? This is just kind of an arbitrary one where it's saying it has m rows and it has n columns. Okay? What those numbers mean can vary dramatically. It's one of the strengths of matrices is they're really versatile. You can use them for a very wide variety of situations, because what they do is they store data and they store numbers. Okay? And again, in the third day, we'll really get into that. The things that we can kind of do with them. So one of the things that we'll refer to as matrices is their order. Okay? What size of matrix do we have? It's a question we often want to know before we do anything with them. Part A, one of the smallest, most simple matrices you could get. That is a 1 by 1. 1 row by 1 column. Okay? When you're talking about the order, just remember that it's rows first. Okay? So in part B, rows go down the sides, and they're just one of them. It has 4 columns, so that matrix is a 1 by 4. And C, that's a 2 by 2. That's the same as part A. That's what we call a square matrix. For determining the order, that's kind of nice because you can't go wrong, right? Even if you're not clear on rows and columns, you know, it's a 2 by 2. Not the case in part D. We got to do rows first. So in part D, that's a 3 by 2. So here's a little sneak peek of kind of where we're headed in day 3. Check out what we have here. Okay, this is a system of 4 equations with 4 variables. Okay, might look a little intimidating. Eventually, we'll solve something like that. Okay, now if you think back to what we've done, you're probably like, well, we've done a 2 by 2, and in chapter 7 we did that quite a bit. We did 2 equations with 2 variables. What about a 3 by 3? That would be the next step. Is we'll solve a 3 equation with 3 variables, 3 equations with 3 variables, I should say, and 4 with 4. But in both cases, we kind of lump them together because we're going to need matrices to do it. All right. So here's where we make the jump over to a matrix. Is we write what's called an augmented matrix. Now I'm going to put my labels up top, that this first column is going to be X, Y, Z, and W. Okay? So each row of this matrix is going to get an equation. Okay? So for example, the coefficient of the first equation in front of X is 1. So right there I put a 1. The coefficient for y is 3. It doesn't have a z, which means that it would be 0. And for W, it's a -1. You don't have to have those dots there, but I like them as a reminder of that's where the equal sign would be. And then the constant on the other side is 9. Okay, so that first row represents that first equation. If you kind of get the idea, it's not a bad spot to pause and see if you could fill out the rest of this augmented matrix. Row 2, which is now the second equation, would be 0, -1, 4, 2, and -2. The third one would be 1, 0, -5, -6, and 0. And finally, we'd have 2, 4, -3, 0, and 4. Okay? So we took that system of 4 equations, which had 4 variables, x, y, z, and w, and we took all of its coefficients and we converted it over to a matrix. Okay? If we were going to solve that system, that would really be step 1, to get it converted to that augmented matrix. Now, once we do that, and we have, and I guess this doesn't really apply to just writing a system of equations as a matrix. You could do these things with any matrix in general. Okay, we have 3 rules about stuff you can do to a matrix that's okay to do. Okay, number 1 is you can interchange 2 rows. Number 2, you can multiply each row by a constant, and this is a big one. Let's call that constant C. It cannot be 0, right? If you multiply a row by 0, no matter what was written, all the numbers in that row are now going to be 0. That we can't do, okay? This is the most important one because you'll find that we use it the most. And in a minute here, I'll show you an example of each. We can add a multiple of any row to another row, okay? So I could take, let's say, the very top row, I could multiply it by 5, and I could add it to row 3. Okay, I'll show you on the next slide as to what that would look like. It's the third one that tends to be a little bit confusing sometimes, but keep in mind, this is it. Okay, this is the only stuff these are literally the only 3 operations that we're ever allowed to do with matrices. So if we head down here, I've got a bunch of matrices waiting for us. Okay, so 1 of each. Okay. Now, one thing you'll find that we typically do is when we go to a new matrix, we'll put an arrow specifying that, hey, there's the matrix I started with. That leads over to this one. Okay? My operation in part A is to interchange the first 2 rows. So notice I'm filling in row 3 because this operation has nothing to do with row 3. Okay, that's not going to change. What I am going to do, and here's how the notation would work, I do kind of a little curved arrow that'll say R1 here and R2 there. Okay, it means that notation is saying 2 rows were interchanged. What was row 1 is now down here, and what was row 2 is now up here. So that's what interchanging 2 rows would look like. Okay, operation with matrices that is allowed, doesn't change the value. I shouldn't say the value, that refers to a number. Doesn't change the meaning of the matrix. Okay, it's something that you can, a justifiable step that you can do. All right, here my constant is a half. I've got a new matrix to start with, but I want to multiply the first row by a half. So I always write in the rows that are not affected. That would be 3 and 2. Okay? Okay, 1/2 times R1, that notation tells me the row operation that went on is a row was multiplied by a constant. It was a half. So I took that first number of 2 and multiplied it by a half. -2, 3, and -1. Okay? Now let's go down to part C. This is that last one that can be a little bit tricky. I'm going to add -2 times the first row to the third. So here's what's going to happen. Notice I take 1, 2, -4, and 3. 0, 3, -2, and -1. The first two rows of the matrix aren't going to change. Okay? I am adding to the third row. In fact, I'm taking -2 R1 and I'm adding it to row 3. Okay? The only thing that's going to change is the row that's being added to. Okay? So now I've got to pay attention to row 1 because that one is involved as well. So I am taking the first digit in row 1, which would be 1, and multiplying it by -2, which would be -2. And then notice down here, that's what I'm going to add it to. And -2 plus 2 is 0. Next up would be 2. I'm now looking at this number. I multiply that by -2, and then I'm going to add 1. Okay? So that would be -4 plus 1, or -3. Now I move over to here. -4 times -2 is 8, plus 5 is 13. 3 times -2 would be -6, plus -2 would be -8. Okay? So again, the step there was, took row 1, went one entry at a time, multiplied that value by -2, and then added it to the corresponding number that was in row 3.